Hello, hi, good morning. So yesterday we did a little revision for the matrices and determinants we did. Revision means whatever the concept we have done, we did the questions on those basis. So for me that is revision only because whenever we do questions, no, so we'll be able to revise the concept also. And of course, when the concept is revised, we know how to apply it. Answer will be there. So easy process. All right, and today we'll do determinants. New topic I'll start today. Okay. The main topic is today's topic is properties of determinants. I'll do. We have already done determinants. We have already done minors and cofactors. We have already done. So today my topic is properties of determinants. And very soon I'll be doing this applications of determinants. Okay, and then we'll be finished with the chapter. All right, just giving you the recapitulation of determinant. What is the determinant? A determinant of the third order, denoted by that thing, consists of 3 rows and 3 columns. Simple. No rocket science. Minor. How we obtain minor? Mij. Mij means wherever it is, in which row, in which column, leave that. Okay, suppose if I am talking about M11. M11 means first row, first column, leave them. Which things are left? Which numbers are left? B2C2, B2C2, B3C3, B3C3. Okay, the numbers which are left, we will find its determinant. That is nothing but minor only for any. Alright, same ways if we have to find M21. 21 means second row, first column. This is second row, first column. Which numbers are left now? B1C1, B3C3, B1C1, B3C3. We'll find its determinant. So how to find the determinant? Here I am finding determinant means we'll multiply B2 and C3, we will multiply. Diagonally again we will multiply C2 and B3 and then we will subtract. This is the determinant. Similarly, if I'll find the determinant here, what it will become? B1 C3, C1 B3 and then we will subtract. Diagonally we have to multiply and then we have to subtract. Similarly, diagonally we have to multiply C1 and A3 and then we have to subtract. Okay, so for 2 means second row, second column. Which 4 numbers are left? A1 C1, A1 C1, A3 C3, A3 C3. All right. Note it. Just one heading, you just put recapitulation and note it quickly. Otherwise, you will be having these PPTs you will be getting. It will be uploaded, no? So again, whenever you want to visit, you can see the video once again. Anytime, n number of times you guys can see the video. Done? Next is cofactors. This also we have already done. Cofactor definition is nothing but Cij minus 1 raised to power I plus j m into ij. Whatever the minor we have got, suppose minor of 1, 3, we have got as minus 1. Okay, and we have to find the value like cofactor of C13. What we will do? Minus 1 raised to power 1 plus 3 m of 1 3 minus 1 raised to power 4 is power is even, so it will become positive number. So this is positive, this is negative. When you will multiply, answer will come out to be minus 1 only. Or if you will get confused with this minus 1, so suppose this is minus 2, then you will multiply with minus 2. This is plus sign, this is minus sign, plus minus is minus. Okay, don't, I mean, why I have changed that minus 1, don't get confused that this is minus 1. This is the formula only. Note it. Next, first property is, first property is not there, that I'll write it. This is first property only. I'll, whatever the property will be left, that I'll write it. Okay, so properties I'm starting now. If any two rows or two columns of a determinant be interchanged, interchange means, suppose this is the first row and this is the second row. I am interchanging, that means A2 will go up, A2, B2, C2 has gone up, A1, B1, C1 has come down, and A3, B3, C3 is having the original place. Okay, interchange means they have shifted or changed their positions among themselves only. So now what it is saying, the value of determinant is changed in sign only. Suppose this value is coming out to be 2, suppose. So this value will come out to be minus 2. Only sign will get changed. Numerically it will remain same. Or if this is delta, then this will be minus delta. Okay, numerically value will remain same, but only the sign will be changed. Note it, this property. So when I'll do the example also, then I'll tell you. Quickly, only just note this statement only. No need to go for this. This much proof no one is going to ask. Only you should know these properties, because when we'll do the questions, no, when these properties will be applicable, then we should know. Quick, this is the proof of that only. Okay, the value of determinant remains unaltered if the rows and columns are interchanged. Now what does it mean? We are talking, see, in this property, two rows were interchanging, okay, or two columns were interchanging. Or means suppose this is column 1, this is column 2. So B1, B2, B3 have come first. A1, A2, A3 have gone at the second column. C2, C3 is at the same position. Either this happens or this happens. Value will be changed only with the minus sign. Okay. This means either the two rows I am changing or interchanging, or two columns I am interchanging. Now, what is the difference between this one and this property? This property means I am interchanging rows and column. That means transpose I am taking. This is nothing but I am talking about transpose. Suppose this is first row. Now this has become first column. This is second row. This has become second column. This is third row. This has become third column. So when this happens, this is nothing but transpose of this matrix. Okay. In this case, suppose if this determinant is delta, then this determinant will also be delta. There will not be any change in the sign also. Okay, so that's why I'm talking about transpose. In transpose case, determinant remains same, but if I am interchanging two rows or two columns, determinant changes with the sign only. There is a difference between these two properties. These two properties are different properties. Note it. This is the, swapping. This is the first. This you can mark as second property. That you can mark it as a first property. No issues. Okay, interchange the slide only. That's it, nothing. Next. All right. Very important one. If two rows or columns of a determinant are identical, identical means same, the value of the determinant is 0. Okay, now what does it mean? See, A1, B1, C1 and A1, B1, C1. Both the rows are same. In this, answer will definitely come out to be 0. How? That I'll tell you. Again, I'll come back to these slides once more. I'll give the example also. Quickly note it. So these properties, see, anyhow, you can't learn it. But when you will do so many questions, no, anyhow, it will be there in your mind. Okay, just read it and automatically it will be pasted in your minds. Copy paste. Okay, read in such a way that it will be copy paste. Oh, now they have given the example only that will solve. Now see, directly I can write the answer as 0. Why? Because this row and this row is same. But I'll tell you the proof. Okay, example I'm taking. Suppose I am expanding the row along the row which is non-identical one. This will be plus sign, minus sign, plus sign and minus sign. Okay. Minus 4. Now where it is lying? In this row and in this column. Okay, I mean this row and this column it is lying. Which numbers are left? 92 into 93 minus 93 into 92. Understood? This product and this product is same. Cancel it. Okay, this will come out to be 0. Now, plus 7. Plus 7. 7 lies in which row? This second row. And second column. Which numbers are left? 91 and 93. 91 and 93. So I'll write it. Plus 7. 91 into 93 minus 93 into 91. Again, product will come out to be the same. Multiplication is commutative, no? It will get cancelled now. Now, which number is left? Minus 11. This row, last column. Which numbers are left? 91 into 92 minus 92 into 91. Cancel them. Minus 4 into 0 plus 7 into 0 minus 11 into 0. Answer will come out to be a big 0. So we don't have to do all these stories anytime. What we have to do is, the moment we're gonna see 2 rows and 2 columns are same, we'll simply write the answer as 0. This is the proof of the third property which we have done. Write it quickly. I'll do the other question. I mean, properties are there, no? Other properties are also there. So for that also I'll do the questions so that you will be able to understand and retain it. Shall I move? Next, fourth property. If every element of any row or any column is 0, only one I am talking about. If one row is also 0 or if one column is also 0, answer will definitely come out to be the 0 only, or we can say the value of determinant will come out to be 0 only. How? See, expand through this only, no? 0 into multiplied anything, 0. 0 multiplied by anything, 0. 0 multiplied by anything is 0. So, answer will come out to be, value will come out to be 0. So, this is again an important property. All the properties are very important actually. Properties means what? Anywhere we can apply it. Shall I move? Write it quickly. Next, all right. Now what? The same property which we have done, no? On the basis of this property, I am taking one question. Sin x, tan x, sin square x, 4, 7, 11, 91, 92, 93. Nothing is same. See, till now what we have done, either we can interchange the columns, we can interchange the rows, we can, what else we can do? Make the all, see, what we have to find is delta of 0. 0 this is delta of x. That means wherever x is there, I'll put the x value as 0. Okay, we'll do sine 0, tan 0, sine square 0. 4, 7, 11, 91, 92, 93. Okay, simply we have put x value as 0. Now sine 0 is what? 0. Tan 0 is also 0. Sine 0, 0. 0 square is also 0. 4, 7, 11, 91, 92, 93. And as I clearly mentioned in your last property, that whenever one full row or full column is 0, determinant value will definitely come out to be 0. So answer is 0 for this. Note it. If he'll ask for some other angle, that x value you have to put there also. Suppose they ask for pi by 2, pi, anything they can ask. It is not necessary that every time it will come out to be 0. It is not at all necessary. Just we have applied the property and we have got the answer. Quickly, next, fifth property. If all the elements of any row will be multiplied by the same number, then the determinant is also multiplied by that number. Simple property, clearly visible. If this row, suppose I am multiplying with any constant number k, its value is suppose d, this value will come out to be k times of d. What does it mean now? If I have multiplied any row or any column with one number, determinant value will come here. Suppose this determinant value is 5, suppose. Okay. If I am multiplying it with 6, 6, 6 and 6, this 5 will also be multiplied with 6 also. What it will come now? 30. So value for this determinant will come out to be 30. Whatever the original value multiplied by the same constant. Okay. Note it. Only this much you can note. If I am multiplying this with 6, so that previous 5 will also be get with will be multiplied with 6. First note the statement and then this example only. No need to copy all these things. So till now we have done 5 properties. Which 5 properties? That I will again explain once more. One more property is also there. Then when that will be finished, then I'll go. Shall I move? Note it quickly. Practice problem. Now what does it mean? What it is saying? If D is this one, P, Q, R, X, Y, Z, L, M, N. Okay. Then find the values of the following determinant. Okay. Now what does it mean? This one. Now this one also. This one. And wait, I'll explain. This is actually not clearly mentioned, or okay. Suppose I am taking this 23 outside. From the matrix, if I am taking any number particularly common, I have to take it from the full matrix. But whenever in the determinant, if I am taking any number common, I can either take it from one row or one column. Matrix and determinant, this property is different. Okay. In matrix, full numbers should be divided with the same number if something is there in common. But in determinants, only either take it out from one column or one row. So suppose I am taking 23 common from the second row. So first row remains same. Second row, I have taken 23 common. So P, Q, R is left. L, M, N is also there. Now, one property I told you, whenever two rows are equal, whenever two rows are not equal, we can say, whenever two rows are same, identical, the answer will come out to be 0. Value will come out to be 0 for the determinant. 23 into 0 is nothing but 0. Note it. So we have to simplify the question, not to make it complicated. Don't make the question complicated. We have to simplify it. We don't have to make it complicated. Okay. Next, write it quickly. Now see what PQR was the first one. XYZ element. Now what I can do? 23 is here also, here also, here also. This 23 I can take common. What I am left with? PQR, XYZ, L. This will be M, not LM. Okay. Now, just now the question is nothing but what? PQR, XYZ, LMN. Which value is there? D. So this 23 into D is nothing but 23D is the answer. Nothing I have done. What I have done is only I have taken this 23 common. And in determinants, if we take anything common, it will either come out from one row or one column. But in matrix, it will come out from the full matrix. From all the rows, all the columns. Quickly note it. Same way as this question, try to do it yourself. 23, 23, 23 I can see. We can take it common. Yes, I said you to solve it, but I am only doing PQR. If 23 I am taking common, X, Y, Z is left. L, M, N is already there. Again, this is nothing but matrix D, determinant D only. 23 into D is 23D is the answer. Notate one property is left that I'm going to do. One property is left that I'll write it. Or maybe it is. I hope you have done. Next, we are moving to the next question. Can anyone think what we have to do here is, till now, what properties we have done? Either we can uh, interchange the two rows. Okay, one property I've done. Second property, what we did, we can interchange the row or column. That means transpose. Third property, what we did, when two rows and two columns are identical, value will come out to be 0. Fourth property, what we did, either of any either of the rows or column is 0, then value will come out to be 0. But here, one property, can anyone tell me, like, can anyone think of the property, which property shall I apply and get the answer directly? Think. 378 as it is, minus 9 to 11 as it is. This number is what? 3 6 are 80. This number is what? 6 7s are 42. This number is what? 6 8s are 48. That means whatever the first row is there, 6 times here also. That means if I'll take 6 common, if I'll take, what I'll be left with? 3 7 8 as it is, minus 9 to 11 as it is, 3 7 8. When I took 6 common, this 3 is left, this 7 is left, this 8 is left. Because when you will multiply 6 3s are 18, 6 7s are 42, 6 8s are 48. Alright. So now when two rows are identical, value will come out to be 0. Okay. So answer is 0. See, here I have to explain you this step also and this step also. Clearly you guys can do it in the one step only. Write this step and write the answer as 0. Who is asking why you have not written two rows and two columns are equal? No one will ask you. Okay. Whenever using any concept, you don't have to write in JMail. Of course, that is a like that. These things you will do it in the rough. Next question is nothing but what? Delta is ax, x square and 1. By, y square and 1. Cz, z square and 1. Alright. If we'll take something common, then also nothing will happen. Anything. This I'll do it later because that property again we have to make this as 0. Before that I'm telling you one property, then only I'll do this question. First we'll do this question. Now 5 square, 5 cube, 5 raised to power 4. Again, so before that property will be used, that also I'll do. Before that one property I'm writing now. Before this question I am writing one property. Now one property is there. Property number 6. If the elements of any row if the elements of any row or column is added with any other row or column, then value of determinant remains same. Now what does it mean? Suppose added or subtracted also we can do. Okay, here added or subtracted word also we can do. Added means what? See, I'll tell you what does it mean. One more thing we can write here is if any other row is getting multiplied with, suppose this other row I am multiplying with m also, then also this property is applicable. Now what does it mean? Suppose I am writing 1, 2, 3, okay, 2, 3, 4, 1, 6, 7. Suppose that. Now what we can do is, suppose I am multiplying this row with 2. That means I am multiplying row 1 with 2, okay, and I am subtracting here in row 2. So what does it will become? 1. 1 2 is 2. 2 minus 2 is 0. Yes. Similarly, if I have to multiply this with also 4, like 2 2 is 4. 3 minus 4 is minus 1. Okay. This I am multiplying with 6. I mean 2. So 3 2 is 6. 4 minus 6 is minus 2. 1 6 7. This value and this value, determinant value will come out to be the same. Unaltered word means same. Unaltered. You will see these words means same, identical, equal. These words means same. Okay. So this property we have used. I am doing 2 more questions on this property, then I'll do those questions. Upon that one question I'm doing. This question first I'm doing. Application of this property only, which just now I did. What I can do is 5 square is here also, 5 square is here also, 5 square is here also. So 5 square I'm taking common. This will be left with 1 only. This will be 5 and this will be 5 square, because out of 4, if I am taking 2 common, 2 will be left. Out of 3, if I am taking 2 outside, only 1 will be left. Similarly, 5 raised to power 3 I can take common from the Second row also. So 1, 5 and 5 square is left. Okay. Similarly, I can take 5 raised to power 4 also common. What will be left? 1, 5 and 5 square. When any two rows are equal or same or identical, equal word we should not use here, actually same or identical word we should use. So what will be the answer? Determinant value will come out to be 0. Note it. Quickly. And then I'll do one question on the basis of the property, which sixth property. Quick. Next one question I'm taking. Question is ABC, BCA, A, B, C, B, C, A, C, A, B. This is the question. And we have to find the value of the determinant. We can expand also. These properties, why we use these properties? Just to make it simple. That's it. Don't make it complicated. Now, see, all the three things we can see over here is A, B, C segregated somewhere or the here. What we can do is A is here, B is here, C is here. A, B, C, A, B, C. Now what I can do is R1 I am changing with what? R1 plus R2 plus R3. Okay, in R1 I am adding all the elements of R2 also, all the elements of R3 also. Now what does it mean? R1 I am changing, no? So row 1 only I am changing. Corresponding elements only we have to deal. So B will also get added because R2 we have to add and R3 also we have to add. B plus C plus A, it will become C plus A plus B, it will become. No need to write this, just for your sake I am writing. Okay. And other things will remain same. B, C, A, C, A, B. Whenever we are doing all these altercations, no, whenever we are doing these manipulations, value will remain same only of the determinant. Okay, now A plus B plus C here also, A plus B plus C here also, A plus B plus C here also. Common. Which things is left? 1, 1, 1. Other BCA as it is, CAB as it is. Now why I have done this? Whenever you see ones, make it 0. How? If in column 2, I will subtract column 1. Like this 1 and this 1, if I subtract, first column will remain same only. 1 minus 1, C minus B, A minus C. That means in this element I am subtracting this element. In this element I am subtracting this element. And similarly in C3 also I am subtracting C1. 1 minus 1, A minus B and B minus C. Now what does it be, what will it become? This 1BC as it is, 1 minus 1 is 0, C minus B as it is, A minus C as it is. 1 minus 1, 0, A minus B as it is, B minus C as. Now why I have made these zeros? As I told you before also, so many times I have told this thing, whenever we see maximum number of zeros, we expand through that column or that row. Now I'll expand along row 1. Expand along row 1. This sign will be plus, minus, plus. We don't need that because that is 0 only. So plus 1. Which row and which column will be left? This row and this column we will leave. Which numbers are left? C minus B, A minus B. Which numbers are left? C minus B, A minus B, A minus C, B minus C. Okay, now determinant means what? Diagonally multiply, and yes, outside there is A plus B plus C is going. A plus B plus C is going outside. Okay. So now A plus B plus C as it is, if we'll multiply C minus B and B minus C, and with the minus sign, A minus B and A minus C. A plus B plus C outside as it is. This and this, if you will multiply, it will come out to be nothing but minus sign BC minus C square minus B square plus of BC minus of A square plus of AB plus of AC minus of BC. Okay, BC cancel. Anything else is also getting cancelled? No. So now what it will become? A plus B plus C. If I'll take minus sign common, these all terms will become positive. A square plus B square plus C square. Now other terms will become negative. Minus AB minus BC minus CA. Again we will, if we will do the, apply the formula here, what formula we can apply? A cube plus B cube plus C cube minus of 3ABC. A cube plus B cube plus C cube minus of 3ABC. This is the formula, and this adjust this minus sign, so it will become 3ABC minus A cube minus B cube minus C. This is the answer in the left, in the end. So value of this determinant is nothing but 3 of ABC minus A cube minus B cube minus C cube. Note it down. This is the actual application of the property which I wrote it in the end. We can do the additions also, subtractions also we can do amongst the rows and amongst the columns. Okay. So for today though we'll do this much only. Alright. Tomorrow I'll start with another topic. Done. Tomorrow I'll start with another topic, that is applications also we'll do. But first we'll do, I'll take 2-3 questions of this one and then we'll do the applications. Okay. So I hope today's class is clear to everyone. What we have done, all the 6 properties. Okay. Go through with the properties once again and then go through with the properties once again. Alright. Bye guys. Thank you so much. Revise.